Our powers of 10 table. Let's go ahead and start filling this in. I heard a couple of you guys saying that you had no idea where to even start. What's the easiest problem you see in that table? Friendly. 2.5 times 1. Perfect. Why is 2.5 times 1 the easiest problem in the table? Zach? Perfect, because if you multiply anything by 1, you get the same number. So we could go ahead and start here. So 2.5 times 1 is just going to give us 2.5. So basically today, guys, we are reviewing our powers of 10. This should be review for you. Cool. This should be review for you because we are introducing, or not, maybe some of you have done it before, but we are going to be going over dividing decimals by decimals. All right? Key terms with dividing decimals, I want to go over really quickly. The numbers on, as you guys like to call, the inside and the outside of the house, they have a special name. Does anybody know what they are called? I like where your head's at. He's saying numerator, denominator. I like that. So the numerator and your denominator, the numerator goes inside or outside the house? Inside the house. Good. Everybody knows that. Now, what is the mathematical term for inside the house? Yes. It starts with a D. Yes, sir. Dividend. So if the inside is the dividend, what is the outside? The whole. Yes. The divisor. You will hear that be referred to a couple of times today. Yeah. The answer is the quotient. Yes, I like that. The quotient. That was a nice little addition. Okay, so back to powers of 10. Sorry. Squirrel. Back to our powers of 10. So, y'all told me the easiest part was 2.5 times 1. So, let's go up from there. So, then 2.5 times 10 is going to give me what? Yes. 25. And then y'all just shout it out for me. 2.5 times 100 is going to give me 250. And then 2.5 times 1,000 is going to give me 2,500. And then 2.5 times 10,000 is going to give me 25,000. Wow, okay. So that was really easy. Let's try and go the opposite way. So then 2.5 times 0.1, as y'all would say, instead of 0.5. What is it going to be? Yes, 2,500. Oh, I like that. What is it?
0.25.
Yeah, there we go.
You had the 2,500, sounds good.
Mr. Stark. Oh, sorry.
Mr. Stark. Okay. And then 2.5 times 0.01 is going to give me, Courtney? 0.0. Yes.
That's our dead spot.
That is.
Isn't the whole point of dead spot? Since I seriously every class you do it everywhere and it's like, oh, dead spot.
No, it's that spot right there in the center.
Literally, it's dead center and that's the dead spot.
0.025.
And this piece
Just slightly south of dead center.
Okay, 0.02. Sure. Why not? Okay, and then the next one is going to be 0.0025. Wow. Why don't we move this up? 0.0025. Okay. And then finally we have 0.00025. Perfect. Okay. So we should have these filled in our table. We reviewed our powers of 10. Bring it back in. We reviewed our powers of 10 because it is going to help you immensely today as we begin dividing decimals. All right? So let's try and summarize this a little bit. Is there anything we noticed when did we see a relationship between the movement of the decimal and the number of zeros in the power of 10?
Yes.
Yeah? What is it? They're moving this way, that way. They're moving right, they're moving left. When do they move right?
When they're going up.
When they're going up, so they're bigger than what number? 1. Okay, so we move right when power of 10 is bigger than 1. And we go left when less than 1.
Yeah.
Okay, I like that. Anything else you noticed? We'll kind of put a nice pretty bow on it at the end of this page.
It's still at 25 here.
Yeah, so the root, I guess, of the number, the digits in the number are staying the same. It's just getting bigger or larger depending on what our power of 10 is. Good stuff, I like that. Okay, let's apply this really quickly to a couple of real life scenarios, and then from there we're going to make a generalized rule with our power of 10, okay? So let's say that you're at the commissary, guys, and you want to purchase 10 items that each cost $5.35. How could we use mental math to help us find the cost of the 10 items? Yes. Multiplication, okay, I like that. Now, let's say a package of strawberries, because we live in Okinawa and they're expensive. So one package of strawberries is $5.35. Okay? I want to buy 10 packages of strawberries. How much money can I expect that I'm going to spend?
Over.
Yes?
Over the number that started.
So I'm going to spend more than $5.35. I'm using mental math, guys. So how would I do that? How much money am I going to spend? Yes.
You're probably going to spend a little more than 50 because if you multiply 10 by 5, you get more than 50.
Yeah, you're going to get a little bit more than, yeah. So how can we use our mental math? We can move the decimal. I don't even know why we bother writing on this. Like, you can't see anything at all.
And it's so stupidly
Dead center.
So we can move the decimal.
Move it up. Yeah, okay.
Why is it so expensive?
One place. What direction? To the left or to the right?
Right.
Why?
Because we're going up.
Because the number is getting bigger because it's 10. Okay? We can move the decimal one. So it'd be $53.50. So how much can we expect to spend? About $53.50. So you can use these powers of 10 to help you as you're trying to figure out the cost of stuff. So on the flip side of that, let's say we know what the total is. So the product of, this says the product. What does product mean? What's that? Yes. The outcome of what type of problem? There. Multiplication. Good. So the product of 12.4 and some power of 10 is 12,400. Let's write this out. Let's make it look a little bit more mathy and less wordy. Okay, so the product of 12.4, I'm just about to throw a smartboard out the window. The product of 12.4 and some power of 10 is 12,400. Okay? Yeah, well, that's just the way life works. 12,400. How can we figure out what that power of 10 is? Somebody help me figure it out. I don't see it. Yeah.
You can either count the zeros or it's...
What zeros? Mark? Okay, well, let me finish your strategy. So you say count the zeros. Count the zeros.
Take away the zeros.
Oh, Oh, okay. So I have 2 zeros. So that would be 100.
That would equal to 1.
What's the different strategy that you had, Mark?
Just divide 12,400 by 12.
Yeah, that's a lot of work. You could definitely do that. Chanel, what did you do?
So I know that it started with decimal between 2 and 4. So I counted how many places the decimal moved and it moved 3 places to the right, which means that it was 1,000.
I like where your head's at. So she's saying, I saw that the decimal started between. Oh, I think I just knocked that over.
It just dropped. It's still working.
Where is it? Oh,
No.
this is a fancy. This has got to be the most like interesting YouTube video. I just knocked this down. Can't figure out. It just okay.
Numbers are gone.
Oh, all right.
Broke it. Those 150 subscribers.
Is it even recording?
I don't even know.
So she's saying move between the 2 and the 4. Okay, and she counted. All right, it moved 1, 2, 3. So what power of 10 is going to move by decimal 3 times? Yes. 1,000. Good. 3 zeros. You moved it 3 times. Yes. Yeah, it is recording.
That's fine.
Imagine if it wasn't. That would have been hilarious.
You know, it just life is what you make. All right. Here we go. Keeping it going. So let's generalize our power of 10. Let's generalize this rule that we're seeing here. I like what somebody was saying earlier. I can't remember who about it was Zach about left and right. Okay, so bigger than 1, less than 1. Okay, so I agree with that statement. How many times am I going to move my decimal? What's the general rule? How am I knowing how many times I move my decimal? Like up here in this table, how many times did I know? How did I make 2.5 into 25,000? How did you know that? Help me. I don't see it. How did you know that?
Because it's actually like giving you an idea, like it's 10,000 this way, and then at the bottom it's 1, then the zeros is
The zeros on there?
there's 4.
Okay, so because there was 4 zeros, I had to move my decimal place 4 times. That's perfect. Okay, so let's generalize this power of 10 rule by saying this, all right? So you count the number of zeros in the power of 10. So count the number of zeros. Okay, so you count the number of zeros in the power of 10, all right? Or the number, okay, and then I move my decimal either left or right. So I'm going to count the number of zeros in my power of 10, and then move my decimal to the right when it's greater than 1. So this is just looking like the winding song.
The what one?
Winding.
What's a winding?
It's in Microsoft Word.
There's a font Microsoft Word that just looks like random shapes.
Yeah. So when it to the right when it's greater than 1, or left, I'll scroll it back down after I get it. When less than 1. I use the inequality symbol because hopefully y'all remember those. So I'm going to count the number of zeros in the power of 10, and then move my decimal to the right when my power of 10 is greater than 1, and to the left when it's less than 1. So the whole reason we had to explain this power of 10 business is because as we start dividing, okay, it's going to be important that you remember these powers of 10. It's going to make your life a lot easier. Okay. So when you're done with that, go ahead and turn the page. We're going to start by modeling these problems. Yes, ma'am. What?
Let's get up here.
And? Wait, what? Count the number of zeros in the power of 10 and then move my decimal, so it should be the decimal, to the right, greater than 1 or less than 1. Alright, if you have a highlighter, you might want to get it out to help you color, because it's going to be quicker to color with the highlighter, okay? If they have a highlighter, they don't need
You need a highlighter? What, you steal mine? This one, I guess. I don't know. I'll read it. Okay, read it. Steal it? I'll read it.
No. Okay, so we are going to be dividing decimals by decimals. Guys, I need to reel it in. As you guys would like to say, this problem is 0.9 divided by 0.3. Well, let's actually make this into a mathy term.
Oh my gosh,
Let's make ourselves sound like we know what we're talking about, right? So this is really saying 9/10. I don't. This is saying 9/10.
That's probably not a bad spot.
He's like, that's not the best spot.
9/10 divided into groups of 3/10.
What is that? Is that a double
Okay. So we have here for you to model. We're going to show you this a bunch of different ways today. Everybody learns differently. You're going to see it in the model. You're going to see it division as a fraction, and then we're just going to do old school division with the dividend and divisor. Okay? So starting with 9/10 divided into groups of 3/10. The first thing I'm going to do is I'm going to shade 9/10. So remember, this is hundredths. So this is 1/10, and 1/10 is made up of 10 individual ones. Y'all got that, right? Remember this from elementary school? So 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10.
Which is
Okay.
100.
Oh, no. I didn't mean to take that.
I totally didn't mean to do that.
Okay, so let's go ahead and let's shade 9/10. I want 9/10. That's represented by 1/10,
9/10?
2/10, 3/10, 4/10, 5/10,
I shaded 9/10.
6/10,
I did faster.
7/10, 8/10, 9/10. Okay. So I have 9/10 represented up here. Now I want to divide 9/10 into groups of 3/10. Okay? So to do that, I'm going to look at my model and I'm going to put bars around that. Okay? So I have 3/10 right here. This is one group. I know you know. I have 3/10 right here. That is two groups. I have 3/10 right here. This is three groups. So 9/10 divided into 3/10 gives me 3 groups. Okay? Now let's do this a math way with some numbers, okay? Not with models, but with numbers. So my problem is 9/10 divided by 3/10. Now, if I were going to write this with a dividend and a divisor, maybe on the next page of my notes, right here, where it says stop and think, if I were going to write it with a dividend and a divisor, I have 0.9 and 0.3.
Wait, can you divide?
Now, can I have a decimal as my divisor?
No. Oh, I know.
Yes.
No. Okay, hold
No.
on. I know everybody knows, but I know some of you know, but not everyone knows. All right. So if I have a decimal as my divisor, I need to fix that. Now, what power of 10 can I multiply this number, this divisor by, in order to make it a whole number? That.
No.
Well, I want to make it 3, so how do I make it 3? What do I multiply it by?
3. No.
What
2.
power of 10?
2.
Yeah. I'm going to multiply by 10.
I did it right.
Now, because I multiplied my denominator by 10, I have to multiply my numerator by 10 as well. So now, when I multiply by 10, I'm moving my decimal point one time. My problem becomes 9 divided by 3. And 9 divided by 3 just is 3. Okay.
This makes life so much easier.
So, is our answer bigger or smaller than our starting value? Bigger. Does that work? Can you have an answer that's bigger than your two numbers to start with?
Yeah.
Okay. So then, over here, you could have rewritten this problem as 3 going into 9, which is just 3. Okay. All right. Go ahead and try example 2.
The first thing we're gonna do again, guys, is write this out in Word. Good. So we have 75 hundredths. 75 hundredths. What are we doing? Dividing into groups of how much? What kind of groups am I dividing it into? 5 hundredths. Okay? So basically we're saying, how many groups of 5 hundredths do we have in 75 hundredths? So just like last time, let's go ahead and start with our highlighters. And we're going to highlight 75 hundredths. So knowing that each one of these lines is 10, how many full lines am I going to do to get to 75? Nicholas? 7 full groups. So we'll do 7 full lines. So everybody agree that's 70? Now what am I going to do for the 5? Cut that last one in half, right? So I'm going to color 5 out of that next group, not last. I'm not actually going to get to the last group of 75 hundredths. Now we're going to divide this into groups of how much?
5.
5. So how many groups of 5 do I have? Well, we can just count. Here's 5. There's my first group. Second group. Third. Fourth. Fifth. Sixth. Seventh. Eighth. Ninth. 10th. 11th. 12th. 13th. 14th. And 15th. So how many groups did we end up with? 15. So that's going to equal 15. So going back to what Ms. C was showing us. I start breaking this down. We can start out by rewriting this one as a fraction, right? So I can take my 75 hundredths divided by 5 hundredths. Which one of those do I need to worry about getting rid of the decimals in? The numerator or denominator? Denominator. So if I have 2 decimals, what do you think I should multiply by?
10, 100.
100, right? Because that's got 2 zeros. So I'm going to multiply them both by 100. So it's going to give me 75 and 5, which we know would simplify down to 15, which actually is the number we expected to get after we saw our model, didn't we? How do I write this as the old school division problem? I do 75 hundredths. Remember the winner goes in the house? So my winner goes in the house. Sometimes easier said than done. My loser is on the outside. So what happened when I multiplied by 100? If I have a decimal and I multiply by 100, what am I actually doing? Moving the decimal how many times? 2. Because it's a positive number, my decimal goes left or right?
Right.
Right. So I'm moving my decimal 2 to the right. But I had to do it both on the inside and the outside, right? So I did it to both numbers. So if I do it on the inside, I also have to do it on the outside. Now we're just doing division. How many times does 5 go into 7? 1. Subtract 5 gives me a 2. Bring down my 5. 5 goes into 25 5 times. Subtract 25, that gives me a 0. Even though it doesn't mean I look like it at home, I've written that 7 times already. Okay? So, in all 3 formats, we're able to see our answer is 15. Does that make sense to you guys?
Yes, sir.
Understanding the importance of getting rid of that decimal on the outside?
Yeah.
Okay, let's do one more then. So again, in words, this first one, now I'm saying what? 75. 75 what? Hundredths. Oh, that's what I need to extend. 75 hundredths divided into groups of what? 5 what?
Tenths.
5 tenths. Notice a big difference there?
Yes.
So let's go back to our coloring. We'll start with the outside. So if I'm looking at 75 hundredths, our picture's going to look just like that last one, right?
Yes.
So I've got 7 full stacks. And 5 in that last one. Okay? I'll take a minute, make it look all pretty, and let you guys catch up. So we do 7 full stacks. That gives us the 70 part of the 75 hundredths. And then that last piece of the 5 gives us the last 5 of the 75 hundredths. And put them all together. Now, we have a big difference this time, though, don't we? So I'm not dividing it into 5 hundredths, am I?
Nope.
Dividing it into 5 tenths. So how much is 5 tenths?
5 tenths.
How many?
1,500.
Is that columns, blocks? Why do I get 5 tenths?
You're gonna.
5 whole columns, right?
Yes.
So that's 1 tenth, 2, 3, 4. There's 5 tenths. So that's 1 whole 5 tenths, right? Uh-oh. Do I have another 5 tenths?
Nope.
So what do I end up having left over on this one, guys?
A remainder.
How many tenths do I have tenths?
Yeah, 2.
I have 25 hundredths, don't I? But in 5 tenths, how many hundredths is 5 tenths?
2.
How many hundredths is 5 tenths? 50. So how can I simplify that?
Yes.
What can I divide by?
Divide by 25.
25 and gives me 1 half.
We have to use these graphs because these graphs confuse me.
So-
James.
Again, Waffles, that's the reason we're doing this. There's some people that are going to understand this whole concept better because they've visually seen it. But honestly, this is the last time I ever expect you to use a model. Because now that we've shown you the model and you understand the concept, you should just be able to do it mathematically. So what did we see then? We got equal 1 and 1/2. Let's look at this now mathematically. From mathematical perspective, I started with 75 hundredths and I divided it into 5 tenths. So what I need to multiply by?
10.
10, good, because I want to get rid of the bottom, right? So we multiply by 10, that gives me 7.5 over 5. Now we do that, so let's do this as math. Bye. So, let's put this as a long division. 7.5, top guy goes in the house because he's the winner. Loser's left outside. I just have a single digit on the outside. Do I care if I have the decimal on the inside? No, it doesn't matter. One thing to remember, guys, that decimal always goes straight up, right? So as soon as I start, if you want to just put that decimal up, I recommend it to make sure you don't lose it. How many times does 5 go into 7?
1.
1. Gives me a 2 left over.
Holy, that's bad.
That is bad.
That is really bad.
I think our dead spot is expanding.
Yo, this thing is $10,000 and it has like 5 jillion freaking dead spots.
Not 5 billion, but it's also several years old now. Look at that. I raised it, now it's just fine. So, I have 25. Remember that my decimal's in between. Get down to 0. So, is 1.5 the same as 1.5?
Yeah. Wait, hang on. So how do you know that you have the decimal? I've always been confused about the decimal. So first you 5 goes into 7 one time, so then you get 7.
Then my decimal's here, so go straight up.
Oh, and then where did you get the 5 from?
Because once I did that, I had 2 left over. I just bring the next number down.
Okay.
Then I have 25. Basically, once I place my decimal, I pretend it doesn't even exist.
Okay.
I'm just using numbers. How many times does 5 go into 25?
3 times. So then you have.
5 is 25.
Oh, sorry, 5 times.
5 times. Hey guys, stop the background chatter, please. Not needed. If you have a question, do like what you did and raise your hand.
Okay.
Went into 25. 25 is a 0, so it's done.
Okay. Thank you.
Make sense?
Yeah.
Okay, let's turn the page. Let's look at a couple more problems. We'll do them together. These we actually already saw, because these are our division problems we just did, right?
Can we do these ourselves to see if we know?
So we're going to look and just set them up as division. If I have it written in division form instead of fraction form, the first guy always goes in the house. So remember again, the first guy is your winner, right?
Yep.
So he's in the house, the loser's on the outside. If I have 5 hundredths, how many decimals do I need to move? Places do I need to move? 5 hundredths, guys. How many decimals do I need to move?
2.
2, right?
Yes.
Can I move 2 on the outside without touching the inside?
No.
No. Anything I do on the outside, I've got to mirror it on the inside. So if I do 2 on the outside, how many am I going to do on the inside?
2.
2. 1, 2. 5 goes into 7 once.
So you can,
Goes into 25 5 times. So yes, indeed. We saw once again that it was 15.
so you can just automatically do that. You can just automatically just put the decimal in front.
What do you mean put the decimal in front?
It's like you can automatically just move it twice for both of them. Like it doesn't like change the answer
Nope.
yet.
As long as you do the same.
As long as you do the same thing to both.
Okay.
Just like if it's in fraction form. So in fraction form, I've got to do the same to numerator and denominator, right? If I put it in the division form, I've got to do the same thing to both sides. So the same thing here. If I have 75 hundredths divided by 5 tenths, how many times do I need to move my decimal?
Once.
Once, because there's only one decimal place on the outside, right? So if I move it once on the outside, how many am I moving it on the inside?
Once.
Once. Don't get confused and say I've got to just get rid of the decimal. You don't. You move it the same on the inside and outside. So my decimal again goes straight up, waffles to your point, keeping track of that. If I just move it up as soon as I move it, that'll keep track of where it's at. Then all I got to do is look at the numbers. Again, how many times will 5 go into 7? Once.
No, 5.
How many times will 5 go into 25?
5.
5. So that does say 25 there. Believe it or not. 25. And that also says 25.
Just the best.
There. 25 minus 25. That's what that should say right there.
How many times does 5 go into 75? 15.
Yes. It's just a glitch in the smartboard.
You like kept it updated though?
We've got updated drivers, but this is a really old small. This smartboard's like 7 years old already.
Smartboards are that old?
They've been around for a while, yeah. Okay, I'm gonna give you guys, we'll say 5 minutes to do these next 2 on your own. So no talking, this is individual work. 5 minutes, see if you can knock them both out.
How was that?
Should have been done.
I finished.
There's only 2.
I need one thing. Oh wait, you only wanted us to do the middle 2? Oh, okay.
Guys, quiet down, please. We're going again. Let's talk it real quick. One thing that I was seeing, please remember the first guy is our winner, so he goes in the house. If I've got it written in division format like this, my first guy is the winner. So the winner goes in the house. The loser's left on the outside. How many decimal places do I have on the outside?
You need to move it once.
Once. But I don't have a decimal on the inside.
It's immediately on the very end. It's a whole.
What I do? Where is it at, Michael?
It's behind the 2.
Oh, it's behind the 2 if I don't see it, right?
It's a whole.
So if I move it once, what happens to empty buckets?
0.
They get a 0.
20.
So to William's point, now my decimal's here. If I'm going to put in my answer, I'm going to bring it straight up.
See how it is.
4 goes into 5 once. Goes into 12 3 times. Uh-oh, I'm in a 0. What do I do now?
Put it up top.
0. I still have to have that one, don't I? So I haven't made it to my decimal yet. So my answer is 130.
I got it.
Okay, my next one. Yes, this was designed to test you and see if you would mess up.
I know. I'm very confused on that.
It's 23.
Okay? Do I have any decimals on the outside?
Yes. No.
So do I need to move anything?
No.
No. So my decimal just goes straight up. Will 220 go into 6?
Yes.
No.
No, it doesn't.
What about 62?
Yes.
Yep, 3 times. That actually says 3. There we go. 60 gets me 24. Goes into 24 once. Am I at a 0 yet?
Nope.
Nope, I still have a 4. So now what do I do?
Bring it down. Bring the 0 down.
Add a 0, bring it down. Goes into 40 twice. So I end up with, I'll rewrite it over here to make sure you can see it. 312 hundredths. Thousandths. Guys, you got it?
Yes.
I was so close to each other.
Okay. We are going to give you some more time to practice on your own. Keyword. On your own. Should I be talking to a partner? No, this is on your own. If you need help, raise your hand and I will come by and help you. Okay, you have 8 minutes to do this. 8 minutes, 3 problems should be more than enough. So you have until 11:05 to finish. Where's your paper?
I did something wrong and I just didn't understand what I said. He thought 20 could go into 6. D. This is why we make friends. We should learn how to. Mr. Moore. Life's good, isn't it?
Yours isn't so good.
It's definitely a third grade KMS. I'll take that now.
I'm surprised you'd remember that far back. And he goes in the house.
Oh, I heard that.
Seattle Mariners. Oh yeah, they're freaking good. Jay Bruce, Alex Martinez, son.
Is that like a baseball team?
Yep. I think it's kind of silly how they don't play softball. Yeah. I think it's kind of silly how they don't have like XLs. I don't know a lot about guitar.
I don't know. We're talking about it. No. Wait, what's this?
Right, really clear. There. Go out. Don't start inside. I don't know why
No, that is
everything starts out here. I mean, let me what?
something else. I'm talking about where do they get Giants from? I know it's not football. Yeah, I know this. I'm not talking about that.
Now I just forget the
No, there's a football team. Yeah, in the NFL.
What did you guys get for these ones?
I mean, baseball.
No, it's not 110, it's 130.
We need to work this out because I really fucking.
Yeah, it is.
What is
This is smart.
Yes. Well,
Check my little perfect right
actually,
Oh my god, please don't. No. Please. Patriots now? What did I do wrong?
Start on the outside.
I came in.
You got them. So don't worry. Now bring your duster straight up. No, where's it at?
what's wrong with me? Why is your
That's where you bring it up.
Because you need to make it a.
We go to the 3.
There's nothing wrong with it. This was right here. You guys is back.
I don't know. I just put this on. Mix all stuff on it.
Yeah. Why is? Why?
They're kind of toxic.
What did you say? I'm from
And I'm actually,
from South Carolina, but I live
I'm from North Carolina too.
in California.
Can I use an eraser?
South Carolina.
Can I use an eraser? No, this is not.
You feel quite clearly. It's really simple. You've gotten very good.
So was I. I have no idea where I was born.
But I don't know. Was the like it was they were poisoned down and his parents like couldn't eat it, so they had to move it. Where I Mr. Moore. You guys
It is 1, 2, 3. 1, 2, 3. Waffles. Waffles. What did you say?
Yeah.
Here's a picture of
And then I take it out and no. Then I let it go. And then I put hairspray.
So on number 2. Exactly, on special occasions. But my hair is pretty sick. I think my hair is pretty good. And finish. To remind me. If I put my hair up,
Like hair. But instead, my mom does a braid thing right here, my hair, and then she just ties it. So I have to have it. You know, like a girls' softball team, so we have to use the colors, so they're really competitive.
So am I doing this right so far?
No.
Wow. You just made that way harder than it had to be. Okay, let's go back to our numbers. Let's just write our numbers. You had to write it first time.
So,
You're disgusting. You only needed to move for it. Ladies, bring on it.
I like it, Michael. There you go. Michael, bad ways, bro. I know, but how did you do that with your hair? Bad ways.
What's on the inside?
How many times is 13 going to 78?
That when you're done to straight up. There we go. 13 going to 0. Do I care about a 0 yet? No. Now do I care about a 0? Yes, 0 about 3. I got 13 going to 30. That's 2 bucks. That should be good.
Thirteen times 4. 52. Check my mask. No, I use the decimal, so that's where's the other zebra? There, yeah. Once.
How many were able to finish all the problems?